Hello, everyone. Can you hear me well? Yes. Okay. We are going to talk about performance-oriented Spring Data, JPA, and Hibernate. There is a saying that there are two types of people, those who do backups and those who will do backups, and I believe this is the same with performance. So there are either people who already care about performance or those who eventually will, because if you don't care about the performance and you use such a high-level frameworks, eventually you will hit some performance issues. So why are our applications slow? People give like different explanations, especially when you start having issues on production, then developers tend to find the reasons elsewhere, right? So it used to be common to say that Java is slow, and some people still believe that Java is slow, but I believe most of you are Java developers, because otherwise it wouldn't make any sense, right? So we know that Java is definitely not slow, and it has been already proven quite recently with this 1 billion rows challenge, where Java was able to process like 1 billion rows in less than 2 seconds. With some hacks, but still, Java is definitely not the bottleneck here. So then it's a so if we see that application is behaving slow and you can see that, let's say, the CPU is jumping, we just say that we need more instances, so we just scale up. The other option is that it's a database, that just the database is slow. We just reach the limits of the database, so what we have to do is to get a bigger instance. And this is obviously an option, and sometimes it's exactly the right thing to do long term. More often, it's the right thing to do short term, when we just need to be able to handle the load, but the indicator is that probably the problem is elsewhere. So while it's convenient to blame Java or database or someone else, the truth is that most likely the problem is either in our code or in the frameworks that we use, or rather the way we use the frameworks. So the performance can't be really an afterthought. With these frameworks, it's very likely that you will hit some performance issues, even if you have relatively low traffic applications. So why is it actually slow, like in real life? I work as a consultant freelancer, so I switch projects quite frequently. And in most cases, I see that people make following mistakes or basically has such a problems. So first of all, there is a poor database connection management. Then application executes too many queries. Often these queries are slow, and this is often a result of wrong JPA mappings. Because of exactly the same reason, they fetch from the database much more than it's actually needed, so they cause much more traffic on the network and also much more work for the database to fetch the data either from the disk or from the memory. Ideally, we should not guess what is actually a problem, especially when we have already a production running application that is facing some performance issues and we have to urgently fix it. So if we don't want to guess, we have to have some ways to find out what is wrong. One way to do it is to just enable logging, right? That we will log the SQL statements, and this is the easiest one that we can do. Although enable SQL statements logging in production, it may not necessarily be the best option because you will basically flood the whatever logging system you use. Another option is to use tracing, distributed tracing. So if you use OpenTelemetry or Micrometer or basically like anything, it's very easy to plug it in, and what you will get is like the whole timeline of what happened when the request was executed. And this is a screenshot from one of the traces from the Datadog, from the actual production system that I worked with. Each of these purple squares is a one query to the database. So you can see it doesn't really look good, right? But it actually looks much worse. Oh, sorry. Let me show it again, because I was super proud of this. My clicker is not cooperating. So Doesn't look good. It's already like 5 seconds. Lots of queries. But then, this is just amazing, right? Because it looks horrible, but in fact, this is really like zoomed out. Like if we would zoom in, we will find that each of this thin purple line is actually like 5 more lines. And until we had this distributed tracing, nobody knew that this is happening. Because when you look at the code, it looks quite decent. So that's option number 1. Another option, especially when you use local development, for local development, you can use one of these new tools called Digma. It also uses OpenTelemetry. The great benefit of it is that it shows you exactly inside of the IDE where are the suspected issues, right? So in this screenshot from their website, they just showed that, oh, this endpoint can actually cause n+1 problems. I'm not going to use any sophisticated here when I will do the demo. I will just use the standard logging, because this is something that you can also just go back to work on Monday or tomorrow, maybe, if someone does, and just try it out. And we will start with the database connection management, because before our code can actually execute any query, it has to have a connection. And I believe that you don't really think often about the database connections, because this is something that the frameworks we use just do it for us, which is great, right? This is, let's say, a relatively low-level thing. But there are some hidden traps. Okay, so when the application wants to get a database connection to run any query, it does more or less something like that. This is not like exactly true, but simplified true, right? So the application needs a connection. It goes to the data source, asks for the connection. Data source then uses JDBC driver. It can be Postgres driver, MySQL driver, or anything. And it goes to the database to get the actual network connection. Oh, so disappointed with this clicker. So that's the network. And the network is relatively slow. To create a network connection, it has to open socket, create TCP handshake. There are some encryption, authentication. This just takes time. Like the network call in comparison to any in-process call is just like eternity. On the database side, there's also a lot of happening. So in case of Postgres, each new connection is handled by a separate operating system process. Each of these processes consumes like 5 to 10 megabytes of memory. And this, of course, means that the CPU has to switch the context between these processes. So there's a lot of effort on the database side too. So we can very easily end up in a situation when we have like a super short query to execute, but it takes a long time to establish the connection. So overall, it takes a lot of time. And I believe nobody has had this issue in past, let's say, 15 years, because we all use something that is called connection pooling. And this is like the industry-approved method to handle these kind of situations. Connection pooling works in a way that on application startup, it creates a pool of connection. And then whenever the application asks for connection, it just takes the one from the pool. And if the pool is exhausted, so all the connections are used, either it throws an exception like, sorry, all the connections are taken, or depending on the configuration, it can like create a new connection on the fly. So this diagram changes in a way that now the application goes to the data source, and then the data source goes to the connection pool. In practice, its data source and the connection pool are pretty much the same thing, but the thing is that it doesn't go over network anymore. So this is why whenever we execute the query, it is like we don't see this overhead of acquiring the connection. But if we say that there is a pool at the very beginning to create with the pretty much fixed size pool, fixed number of connections, how big the pool should be. Like if we take a step back, assuming that we run Spring Boot with default settings, it runs on Tomcat. Tomcat has 200 threads that can handle 200 requests at the same time. Spring Boot uses by default the Hikari connection pool, which by default has 10 connections created on the application startup. So something is off, right? The math doesn't really, I mean, it seems like it doesn't make sense, because what these numbers should be when you want to handle, let's say, 1,000 or 10,000 users at the same time. Like maybe you should have a pool with 1,000 connections, maybe one connection per user. Not really, right? It probably wouldn't make sense and no database would handle it. On Hikari CP website, there is a very good article about the connection pool sizing, and they basically say that if you have such a large number of users, you still want to have a very small pool with just a few dozens of connections. And the point is that the overhead of switching work between these connections is really greater than the benefit of running these queries at once. Because if the database is already so busy with executing small number of queries, asking it for more would not really help much. So there are some equations that will tell you what should be the size of the pool. But if you have already running application with already high traffic that is already struggling, trying to change the size of the connection pool can end up in quite dramatically, right? Because either there will be too many or there will be too little, and things can explode. And depending on how important the system is, it's a risk. Like it's a serious business risk. So what you can do, or what you should do, is to make sure that we handle these connections for as short time as possible. So this means we have to optimize the queries, so no slow queries, but also we have to have a good connection management. And when I say good connection management, if someone is puzzled, then it would be right, because we don't manage connections ourselves. This is why we use high-level frameworks to do it for us. But the reality is a little bit surprising, let's say. Do you know when the database connection is acquired and when is the connection released from, like looking from the point of our code? We will see in a second. We are going to use two tools. One is FlexiPool. Anyone knows it? There's one person that knows it. This one person is a fan. No, I mean, this is made by Vlad. Vlad doesn't need any introduction, right? He made this tool. It's pretty fantastic. The goal of it is actually to help you to find the proper size of the connection pool. We are going to use it for the logging purposes, because it shows you exactly when the connection gets acquired and when the connection gets released. The problem with all these logging tools for the data source is that plugging them into Spring Framework or Spring Boot is difficult, to say it nicely. So there's another hero of today. It's Artur Hawliukowski. And he made a project that lets you integrate a couple of different data source proxy solutions that are meant exactly for kind of debugging, tracing, logging, and so on. And one of them is the FlexiPool from Vlad. The tool from Artur is so good that I believe it should be integrated into Spring Boot, or Spring Boot should come with something like this by default. Okay, we are going to switch now to the code that I hope that it's going to work. But
oh my God, that wallpaper.
Which one? Oh, this one. Oh, okay. I have a better one on my screen, but maybe later.
Maybe we don't want to see.
Yeah, it's like feeling a little bit retro. Okay, but I have to switch to mirroring. All right. Now you can see my code, and now you can see my other wallpaper. Good. So I have like a little application that is made of two parts. So the first part of the show is the connections part. So in the connections part, we have a service that has a couple of methods. All of them are annotated with transactional, like we normally do. And then there is a controller that calls these methods. And I'm a serious developer, so I have a test for that, right? And this test doesn't really test anything. But it calls each one of these methods. And I have already plugged in the flexi pool and the data source decorator because the plugging in is actually trivial, so not worth wasting your time. But we will see here how long did it take to, how long the connection was leased. So let's take a look at the first method, which is hello method, right? And what it does, it just goes to the database and finds all entities like of type person. And this repository is just a plain Spring data CRUD repository. Nothing fancy here. It's also not the database with like a huge amount of data. There's actually, I believe there's nothing here. Oh, so how long the connection can be acquired? Should be like milliseconds, maybe, right? But if we look closer, the connection was the connection was acquired actually in zero milliseconds, which is good because the pool has all the connections available, but it was leased for 210. So quite a long time for executing a simple query that returns 0 results. What is happening here? Anyone has any ideas? Just by looking at the code, I like roughly very quickly showed actually where could be the problem. Yeah, something like that. So we have this controller method that calls the service, but here it also makes the external call. And external call is just a sleep. So this is something weird, right? We have marked explicitly this method as transactional. So I would understand it in the way that we tell Spring that this is where I want to open the transaction, this is where I want to close the transaction, and this is where basically my interactivity with the database ends. But it doesn't work like that, at least not by default. If you look into the logs, you will find that there is a warning every time you run a Spring Boot application about the Spring JPA open in view, which is enabled by default, and therefore the database queries may be performed during view rendering. We didn't do any view rendering. We actually didn't need it at all. Like, not sure exactly. This is probably from some historical reasons. The open in view means that you can, let's say, render HTML page with some entities that are not fully loaded, and then if the HTML page needs some more data, then it will fetch it additionally. In our case, we don't need it. We actually not even don't need it. We don't want it, right? We want to make sure that whenever this method ends, the whole thing with the database is over. And then there is a very easy way to disable it. We go to application properties. And by the way, there's also nothing fancy here. And we just say that open in view, change it to false. Now, if I run this test again, it's going to take like few milliseconds only, as expected. Then let's go to another typical scenario. We have a transactional method, and this method makes an external call. And by the way, there's nothing surprising in the controller. Everything that is interesting is happening right now. So once we fix this open in view, we know that the database connection should be opened when we enter the transactional method, and it should be closed when we leave this method. So it takes, again, 257, because this takes 200. So this is quite expected. But the question is, can we fix it? Because we don't want to have this connection leased, so not available to any other request that comes when we just make a call to when we just make an external call. There's another trick that we can do. In application properties, we can mark the auto commit to false, which means that whenever we send some, not even send, but whenever we, let's say, make an insert or make a select, or no, rather like insert, the JDBC driver will not commit it to the database immediately. So it's anyway something that we probably want. And as a side effect of it, Spring will not open the database connection until it reaches the point where it wants to access the database. So in this case, it knows that it's in transactional method. This method will actually run in transaction, but the transaction will start here. It will be delayed. So now this should take just 3 milliseconds as expected. And this here we were in a very comfortable situation when the external call was the first thing that we did in the method. it's a little bit problematic more when we have an external call after we interact with the database, because then it means that it has to open the connection here, and it just doesn't know what happens later, right? Maybe the database connection will be still needed. So this external call still occupies the connection without a really good reason. In this case, it's quite easy because we could just remove the transactional, because this will run in transaction anyway. But if there is something more happening here that we actually do want to have this database transaction spanned over like multiple methods, we still don't need to have to, or don't have to, shouldn't use transactional. So transactional is very convenient, right? Because it's a declarative way to say where the transaction should start. But Spring also has something that is called transaction template that lets us start transactions programmatically. And this is definitely underutilized feature. Am I in the right place? No. Should be here. So now with this transaction template, I can explicitly say that only this part of the method should be executed in transaction. And then the transaction here is over and the external call just happens outside. So this transaction template is super nice and known way too little. And we will also see now another use case for it. We have another method, also transactional, that calls another service, and this service, someone decided that it has to be annotated with propagation requires new. So this means that this piece of code will run in a new transaction. Nothing wrong per se, right? But if we look at the cost of it, it's also quite interesting, because now we acquired one connection very quickly, and then we acquired another connection, because when we run something in a new transaction, it means that it also has to have a separate connection if the previous transaction is still running. And then the inner transaction took 400 milliseconds, and then the outside transaction also just have this time included, even if it actually didn't maybe need it. We can solve this problem again with the transactional template. Instead of having this transactional, we just wrap these parts into either this part into separate transaction, and this will be actually enough, right? It's not exactly the solution for all of the cases when we have requires new, because sometimes we do structure the code in a way that this requires you may be necessary, but ideally you don't do it, and especially you shouldn't put this requires new just randomly because, oh, I believe that this will be maybe needed. So that's the part about connections. Once you know that issues like this exist, you probably will find a lot of places in your application where this can be optimized. And once we have the connection management done right, we can switch to the Hibernate and JPA and what can go wrong there. I made like a very simple type of banking application, and I'm already talking like half an hour. That's not that great. So this is a banking application. It has a bank transfer, which is an entity with some sender, receiver, amount, nothing really fancy. Then there is an account, and account is just a very simple entity, nothing really fancy here. And then we have a use case that is very simple as well. So it registers a bank transfer. So there's an account. Sorry, what does it do? It receives a notification that the payment network executed some transfer, and it receives the transfer ID that we should use as a bank transfer ID over here. And then from whom to whom, what's the amount? So when we have this use case, I will run the test that executes it. How many queries would you normally expect? I would expect that this will trigger a select, another one will trigger another select, and then we will have an insert at the very end. Okay, but we have now too much noise. Let me say goodbye to these two libraries. Okay, and the reality is very, very different. So this little piece of code with just 4 lines, and how many mistakes you can make in 4 lines of code? Apparently you can make a lot of them. So we fetch from account, then we make a select to the bank transfer, then we make 2 more selects to account, and then at the end there is an insert. What is wrong here? There are plenty of things. So first of all, if we look at the bank transfer, it has this ID that we assign manually. And when we execute the save on the repository, it goes actually to simple JPA repository and calls this method. It checks if the entity is new, then it executes persist. If not, it executes the merge. But if we assign the ID, it actually thinks that the entity is not new. So it calls the merge. And to call the merge, it looks that, oh, I don't have this entity in the Hibernate session yet, so I have to fetch it. So this is why it executes this select. So to fix it, we need to find a different way to tell Spring Data that this entity is new. And one way to do it is to add the version. When we have a version, this version at the beginning is null, and this will be enough for Spring Data to understand that, okay, the version is null, this entity is new. Alternatively, we can implement a persistible interface where we have a method where we programmatically can say, what does it mean for the entity to be new? But we will just leave it like that. If we run it again, we will see that this select is gone, but it still makes 2 more selects for the account. And this happens because when we try to persist the entity, it finds again, this is not managed, this is not managed, and this is not managed. And this is why, because this method is not annotated with transactional. So it opens a Hibernate session and closes it, opens a Hibernate session and closes it. Once this is transactional, it all uses the same database connection, it all uses the same Hibernate session. And we limit it to the number of queries that I would expect to happen at the very beginning. But if we take a closer look, why do we need these accounts? Do we do something with them? Not really. We do it only to make the Hibernate, or actually the relations we defined, happy. So the bank transfer expects the sender and expects the receiver. We could model it in a way that instead of sender and receiver, we have these here IDs. And this would follow a little bit more like the domain-driven design that Spring Data actually promotes. But if we do it like a JPA way, we can also avoid it. Instead of calling the get method, we can call get reference by ID. At get reference by ID, instead of going to the database, we'll create like an artificial account, which will be like a proxy with just this ID. And it's enough to make Hibernate happy so that it can persist the bank transfer with proper IDs without actually fetching them. So we just limited to 1 single insert. This, of course, has some drawbacks because we don't check if this account actually exists. And if it doesn't, we will get some constraint violation on the foreign keys. Great. So we solved this one problem. Then we have another use case that I will already annotate as transactional, just to avoid okay. So this use case goes to the database, selects the bank transfer, changes one field over here to settled, and then saves it. Doesn't look bad, right? There is a 1 select and there is a 1 update. When we look closer to this select, it fetches from the bank transfer and also joins the accounts. Maybe not perfect because we don't need it, but also not too bad. It does it because our many-to-one associations are by default set to fetch eager. If I don't put it here, it will be eager too. So I would expect that if it's eager, then it means that whenever we need a bank transfer, it also needs accounts. And that's exactly what happens here. But it's not exactly like that. In another use case, I have a method that fetches a list of bank transfers. And if I run this one, the behavior will be slightly different. So it went to bank transfer. There was one join because of the query that gets executed, where we filter by the sender ID. But then for each one of these accounts, we execute another query. This is something that is called n+1 problem, where we execute one query, and then for each of these results, we execute another query. So to change it, we need to first explicitly say that these associations are not fetched eagerly, but they are fetched lazily. And then when we make a query, we explicitly say what kind of associations we need. So we can do it with the query, bank transfer, join fetch, sender join fetch receiver, where b id equals. And in this way, in every use case, we explicitly say what do we need. So we make sure that the Hibernate and everyone involved doesn't do extra work. And these queries get a little bit lengthy, and it's string. It's maybe too easy to make a mistake. So alternatively, you can use something that is called an entity graph, where you just say exactly which attributes path you want to fetch additionally to that. So in our case, we want to fetch the sender and the receiver. I have time till no, I have like lots of stuff to say, so 10 minutes. Okay. Good. All right. Let's take a look once more time at the settle bank transfer use case. So now it will not fetch any more data than we actually need, but we will look closer at the update statement. When Hibernate executes update, it will update all of the columns or all of the fields, all of the columns in the table or all of the fields in the entity, however you want to look at it. This is the default behavior, and it's not necessarily a bad behavior, but if you have either a table with a large number of columns, or you have columns that has some large data, like long text or some binary data, you probably would prefer to update only what has changed. And if you would not use Hibernate, but you would just use plain SQL, you would execute an update statement with only columns that have changed. And Hibernate has also, or JPA, or a function for that. There's called dynamic update. If we annotate an entity with dynamic update, Hibernate will track which fields on the entity have changed, and it will update only those. This comes with a cost that Hibernate has to track it, so it means that in memory it will probably take more. It will take more memory, or it will consume more CPU. I don't have any numbers. I think it's worth considering. I think you can give it a try. Okay, and now I stop the mirroring. I would like to go back to my slides. And I will not do a summary because I don't think I have time for that, but this basically repeats what I just said. So the question is, like, once we polished all of these mappings and we went it really, really nice, how can we make them bulletproof so that you go for holidays and then some new person comes to your team, joins, and basically messes up everything that you have done? So there's one tool, again, made by Vlad. So Hibernate High Persistence Optimizer. Not sure if you have ever used it. It's fantastic. It's fabulous. It's a commercial tool, by the way, but it's like you plug it in to your application. It runs as a test, and then it shows you basically everything that you've done wrong. So I say it's like pair programming with Vlad, but it's a commercial tool, which is great for Vlad, but not necessarily for us, especially if we have to push it through 10 different management levels and ask for buying it. I mean, I would advise you to do so, but I know that it's difficult. So there is kind of like an alternative, not exactly alternative, but something that can help us. And this is done by Jean Bisutti, I guess. And this is called Quick Perf from Performance. So I will quickly very quickly show how we can use it, because I have already configured it in the project. And it doesn't, like out of the box, it doesn't work with Spring Boot 3 because it needs to be updated, but with small little hacks, you can make it work. Let's take a look at this assign phone number use case. Very similar to the one we had before. Finds an account, adds the phone number, saves it. The only difference is that phone numbers is a element collection table with some records, but nothing really fancy. The point here is that we can take this test and then we can say, what do we expect to happen from the database perspective? So we know that we expect just one select. And we can say that we expect one update. And that we expect no deletes. Now, if I run this test, in addition to running my regular test, it will also check the data source if something like this has happened. Something didn't work. 3 performance-related properties are not respected. Oh, you may think that there was 1 select, but there were actually 2. Whoa, I actually didn't expect even this to happen. But the more interesting is that there was a delete statement executed. Well, this should be a surprise, right? Okay, because it selected the phone number, but also in the middle it executed the delete. And I will not go now into details why. You can do this as a homework, why it executed a delete. But it's a very interesting thing. Good. Now I'm going back to slides and all right. So these tools, 2 tools, fantastic. So the entities. Oh, there's a lot of bad things about what we just seen, right? Because we've seen the code that from the outside looks perfectly fine. If we start to look deeper, we find that this is not performant at all, and we have to do a lot of things that are like small little tweaks to actually make it work properly. So there's a lot of overhead when we use Hibernate. When first it fetches more data than we usually need, like in comparison to writing plain SQL query. All these entities end up in the persistent context, so it occupies the memory. Then it tracks if it's changed, so it occupies the CPU. And then we have this risk of n+1, which also kills the database. But entities are in general good because we can use object-oriented programming to ensure that certain business rules happen, right? That we enforce invariants. In all of these examples that we had, or most of them, we were actually modifying these entities. So the conclusion is that we should fetch an entity only if we have an intention to modify it. But if we just want to fetch it for the sake of loading the data with no intention to modify it, we should fetch projections instead. As an example, we have this account entity, and we need to present to the user or to whatever consumes our API just this little JSON with some basic information. We could fetch this entity and then have a record like that and just map it either manually or use some awesome mapping framework. But we don't have to. We can have this projection class, so we call it now projection class, and then add a method to a Spring Data repository that will just return this projection class. And Spring Data is able to somehow magically figure out what it should fetch and how it should fetch it. So it looks into the return type of this method, checks the fields, looks at the names of fields and how they map to an entity, and it looks at the method name at the end of it, what the where clause should look like. And it just generates exactly the SQL that you need. So pretty much with zero overhead, we have the same result with actually less coding from our side. And in addition, we get the performance. So that's awesome. But if it looks scary for you or your records for some reason don't match exactly the entities, you can also fetch these entities these projections using the JPQL query. You can even fetch them with plain SQL with this one drawback that then the projection has to be an interface, which for me looks completely odd. Like the records as a projection Nice. Interfaces as a projection, super weird. I don't like it. All right, and once you start using these projections, you will quickly find out that, damn, you have now so many methods in the repository because each use case requires probably slightly different shape, right? So we fetch these names, but then we fetch like an account with a couple of properties. Then someone comes and yeah, let's do like a DTO. And then you end up with this repository with the methods that first of all have like completely bizarre names. The data types also are pretty meaningless. And also the repository holds the knowledge about all the use cases in the whole system. So that doesn't really look good. And then it comes another feature of Spring Data, which is called dynamic projections. So in this case, you can just have one single method on the repository meant for fetching projections, and you pass the shape of the projection as a second parameter. So one benefit of this is that the repository doesn't look so ugly anymore, but it also doesn't grow together with the application. The repository class is just super lean. You don't have to add some extra tests to it. You can just test your use cases. The only drawback is that then you can't really write a custom query. The where clause has to be only like resolved from the name of the method. So we have these projections, we have entities, a lot of magic involved. And I just would like to tell you that, you know, you don't have to use Hibernate. Because with all the benefits of using Hibernate, there is a lot of learning, a lot of places you can make a mistake, even if you are experienced. And sometimes using SQL is just exactly what you need. SQL is also very high level. It's also very convenient. So just keep it as an option. Takeaways. JPA and Hibernate are not easy. Using them as a first tool, like after you learn Java and then you want to persist something and then use Hibernate database, I think it's a mistake. So like it's like a lifelong studying of JPA and Hibernate. You have to get the connection management right, because this is where the bottleneck can really be serious. During development, either log queries or use Digma to see exactly what it happens. I would recommend to not trust what you see and maybe don't even trust yourself. It's better to log these queries. Also consider getting the optimizer for Vlad or use the quick perf for testing. And definitely you must use projections for reading the data. At the very end, I would like to thank these two gentlemen. So Vlad and Torben, they made more to Hibernate than anyone on the planet, like including Red Hat, except writing Hibernate, right? But at least about educating. Because most of the things that I know actually from these two gentlemen. And that's it from my side. Thank you.